Okay, these are the Algebra 2 10.3 notes. So, first of all, we're talking about just in general the trig functions that we have. So when we actually go and we want to find like the sine, cosine, tangent, etc. of an angle, these are the trig functions. Okay, so from this angle that when we're looking at and we're trying to do, and we're doing sine of angle theta, theta is just the angle. So if you picture like where this point is, it doesn't matter which quadrant it's in. So this is in quadrant 2, but it could be in any quadrant. If you picture it creating a triangle down here, all right, and so then the x is this distance and the y is this distance. And so if you want to know, and then also I guess the radius, if it's not on a unit circle, then the radius can be any number. If it's on a unit circle, then we know it's 1. So if we want to do sine, then we're going to do opposite over hypotenuse. So that's y over the radius. And if we want to do cosine, cosine, remember, is adjacent over hypotenuse. So like from this angle, the adjacent side is x over the hypotenuse is r. So x over r. And then tangent is going to be opposite over adjacent, so y over x, remember, because of SOHCAHTOA. And x cannot be equal to 0, and that has to be stated here. And so then if we want to do cosecant of theta, then remember that cosecant is just the reciprocal of sine. So if sine is y over r, then cosecant is r over y, and also y cannot be equal to 0. Because you could have a point on a graph that involved a y value that was 0. Cosine, remember, is the reciprocal of secant. And so cosine is x over r, then secant is r over x. And x cannot be equal to 0, that's just a point they make. And then if tangent is y over x, cotangent is the reciprocal function, so it's x over y. And remember that y cannot be equal to 0. And they go ahead and they don't have to say r cannot be equal to 0 on these two, because wherever your point is, it's not going to be at 0, 0, or just this wouldn't exist, the angle wouldn't exist. So any point that's not on 0, 0 is going to cause us to have a radius that's a number, not 0. So that's why here on sine and cosine, they don't write r cannot be equal to 0. Okay. So it says, let -4, 3 be a point on the terminal side of an angle in standard position. So this is not necessarily a unit circle, because -4, 3 does not necessarily end up with a radius of 1. So this is just a circle, not the unit circle. Okay, so -4, 3 would be right here. And it's a point on the terminal side. So what that tells me, if this is the terminal side, remember that in standard position, your initial side is over on the x, the positive x-axis. And so then it tells me that it's going this way. Okay, and so this right here, the side would be 3. This side right here of this triangle would be -4. And if we want to find the hypotenuse of this triangle, then this triangle, we would do 3 squared plus -4 squared equals the hypotenuse I'm going to call the radius, or c squared, it doesn't really matter. And so then we would end up with finding out that this makes 25. So then that tells me the radius is 5. All right, so if I want to go ahead and I want to find the 6 trigonometric functions, so sine is opposite over hypotenuse. So I'm going to do from this angle right here, I'm going to do 3 over the hypotenuse is 5. So then on cosine is adjacent over hypotenuse, so that's -4 over 5. And then tangent is opposite over adjacent, so that's 3 over -4, which you would typically not put the negative down with a 4, you just call it -3/4. So then if we do cosecant, remember that's the reciprocal of sine, so it's 5 over 3. Secant is the reciprocal of cosine, so that's -5 over 4. And cotangent is the reciprocal of tangent, and so that's -4 over 3. All right, and so that would be our 6 trig functions. And remember, this is not on a unit circle, it's just on a circle, it's just graphed, because that means the radius is not necessarily just 1. All right, this says use the unit circle to evaluate the 6 trigonometric functions of theta when it's 270 degrees. Okay, so what we're going to do is we're going to look at our unit circle. So if you look at our unit circle, we have that one that we filled out the other day. So if we go back here and we look, 270 degrees is right here, and notice it's this point here at 0, -1. All right, so let me just show that to you. I'm just going to make a little rough sketch over here of it. All right. So it is right here at 0, -1. That is 270 degrees. Okay, so something that you need to know about the unit circle that we're just introducing today is that when you are trying to find a value on the unit circle, and this holds true every single time, the cosine of theta is the x value and the sine is the y value. So every single time when you have a point, the x value is what cosine is and the y value is what sine is. So when we say what is the, let's actually start with sine. What's the sine of theta, which in this case we actually know what theta is. So if we go through and we say, instead of theta, let's clean that up. Let's put what's the sine of 270 degrees. Well, the sine of 270 degrees is the y value of the point where it is at, which is -1. All right, and then the cosine of 270 degrees is the x value, which is 0. And then another fact you need to know is that tangent is always sine over cosine, which we learned back in geometry, but a refresher here. So these would be very important information. So if we're finding the tangent of 270, it's the sine of 270 over the cosine of 270. But since it is dividing by 0, it is actually undefined because remember, you cannot divide by 0. All right, so now if we go and we do cosecant, remember that cosecant is the reciprocal of sine. So if the sine is -1 over 1, think of it like that. Then when we flip it upside down, we have 1 over -1. That's the reciprocal, which is just -1. And on cosine, think of cosine as 0 over 1. Anytime you have a whole number, you just put it over 1, which is just 0. So the secant, remember, is the reciprocal of that. So instead of 0 over 1, it's 1 over 0. You can't divide by 0. So in this case, the secant is undefined. Anytime you have dividing by 0, it's undefined. And then the cotangent. Remember that on the tangent of 270, it was -1 over 0. And because it's dividing by 0, that's why it's undefined. Okay, so go back to this. The reciprocal is 0 over -1, which is just 0. And so those are the 6 trig properties. Okay, so, all right, so I'd like to go over here and just try on the self-assessment right here, numbers 1 and 2. So go ahead and just give them a try, pause the video, and then we'll come back on and I'll give you the answers. Okay, so I went ahead and just to take note, when I found the radius, it was the square root of 18, so I simplified the radical, and I got 3 square root 2. So then when I was doing this, the hardest part, it was not hard to set up opposite over hypotenuse, but then I had to multiply by square root of 2 over 2 to rationalize the denominator and get it as a whole number, and then simplify the fraction. So that wasn't exactly fun. On cosine, it was the same problem, just positive. So instead of doing all that work, I just was able to take the answer from sine and make it positive. Tangent was much easier. And then cosecant and secant were much easier because I went to this beginning spot and I just did the reciprocal. And then I simplified the 3 over -3, and that's how I got this negative square root of 2. Same thing for secant. And then on cotangent, it was just the reciprocal of tangent. And then here is your answers for number 2. Okay, so let's go take a look back up at the examples that we were on. All right, so a reference angle. All right, so the reference angle is just an acute angle. and they label it theta with the little apostrophe, okay, so like theta prime, and it is formed by the terminal side of the original angle of theta, so theta prime is the reference, theta is the original, and the x-axis. All right, and so we're just going to go ahead and I'm going to show you the 4 different examples depending on which quadrant it is. So if you just want to set up your 4 graphs here, and I'm going to switch colors so that it shows up. All right, and so if it's in quadrant 1, then the reference angle and theta are the same. They're literally the same thing because the terminal side and the x-axis are the exact same thing. All right, if it shows up in quadrant 2, that's like this. So this is theta right here, and then its reference angle is this right here. And so how you find the reference angle when it's in quadrant 2 is you take 180 degrees minus the original angle, or if you're in radians, you take pi minus the original angle. That's if you're in quadrant 2. All right, if you're in quadrant 3, so if you're down here, then your angle theta is formed right here. And so how you find your reference angle is it's this angle right here. It's between the x-axis and the terminal side. How you find that is you take, to find your reference angle, you take your original angle and subtract 180 degrees, or your original angle and subtract pi if you're in radians. That's for quadrant 3. That's the formula. And if you're in quadrant 4, that's down here, keep in mind that the way the angles work, you're going this way. So this is your angle. If you're in quadrant 4, your reference angle is right here between the terminal side and the x-axis. So to find that, you would be taking 360 degrees minus your original angle, or if you're in radians, 2 pi minus your original angle. All right, so pause the video if you need to right there and write down the formulas. So on this one, your angle is 5 pi over 3. The key is figuring out which quadrant you're in. So if you think about where 5 pi over 3 would be, keep in mind that like 3 pi over 3 would be pi. So if you're at 5 pi over 3, you're past 3 pi over 3. So if I think about where I am, I can always look at my unit circle to kind of help me figure that out. And so where I am, I'm actually right down here, and that's in the 4th quadrant. And so if I want to find my reference angle, which is right here, and remember, if you're in the 4th quadrant, you do 2 pi minus your angle. So you could use a calculator, and you could literally do 2 minus 5/3. Just leave off the pi's. And so if you use your calculator and you type in 2 minus 5/3, you're going to get 1/3. And so that's 1 pi over 3, or just pi over 3. All right, so think about where this one is. So if you are right here at negative 130, so keep in mind, if you're negative, you're going back 90 and then another 40. It's like here-ish. So if you want to find your reference angle is between the terminal side and the x-axis. That's right here. And so if you want to find that, you're finding out how big that is. So what I would do, in that case, keep in mind you're in the 3rd quadrant. Now this is a little different because you're negative. So what I would personally do is I would do 180 minus 130 degrees. And what you're finding out is that this is 50 degrees. So your reference angle is 50 degrees. So it's a little bit of common sense. All right, so on this one, this is negative 240 degrees, which makes sense that it's in the same place as 120 degrees. So if you want to know the tangent at negative 240, it's the same as the tangent at 120, which is the sine of 120 over the cosine of 120. I'm going to pause for a minute and look that up on my unit circle. You should too. All right, so remember that my cosine is my x value, my sine is my y value. So my cosine is negative 1/2, my sine is square root of 3 over 2. All right, so if my cosine is negative 1/2 and my sine is square root of 3 over 2, because they're both over 2, I know that they're square root of 3 over negative 1, which is negative square root of 3. The other way I could do that is I could multiply by the reciprocal right here. And so this cancels out, the 2's cancel out, and I have negative square root of 3.